Okay. Hi, everybody who's joining us now. Hi, Phil. Nice to see ya. We're getting ourselves up on YouTube now, and then we'll be ready to go. Thanks, everybody, for spending your Tuesday afternoon with us. There we go. Okay. It is officially 3:30, and so I think we should get started. So welcome, everybody who's joined us. Hello from all around the world. I'm really loving that Horseshoe Bay, that Joseph, you keep coming back. We always seem to get people from Horseshoe Bay, and it makes me so happy. Today's topic is a slight divergence from what we said last week. Chris and I both misspoke in our last session. So we did mention that it was going to be telescopes, but today it's actually going to be double stars and easy binocular targets. And we have our guest, Blake Nancaro, with us here from RASC Toronto Centre, who's going to be talking about double stars. We're going to start off the session, though, with a little bit of space news and what's coming up this week in astronomy with Chris, and then Blake's going to jump in with double stars. We'll have a bit of a Q&A about double stars, and then we're going to wrap up with some bino targets. Thanks, everybody, for joining. We're so excited to have you. Chris, do you want to kick us off with what's going on this week?
All right, let me just get my slideshow up here and share my screen. Doing it a little differently here. So there we go. Share screen, screen 2. And I'm going to take you guys off of there and say go. So I thought I'd talk a little bit about the moon just to kick things off, because that's what's dominating the sky. And that's also the reason we have our friend Blake on today. This is the week of the month where we get the full moon. And when the moon is full in the sky, it's essentially overwhelming just about everything else that we astronomers like to look at. But why not make some lemonade? So what I thought I'd do is highlight some of the things that are happening on the moon, things that you can see in binoculars or with your unaided eyes or with a backyard telescope. So we'll spend a few minutes looking at that, give you some quote unquote homework that you can head out and look for over the next few nights. So first of all, in terms of what's happening in astronomy this week, we have a meteor shower that's peaking overnight on Wednesday and into Thursday. But normally this is a sort of a medium grade meteor shower with a few dozen meteors per hour at the peak. But unfortunately, we have the full moon in the same sky as the radiant of the meteor shower. So that's going to overwhelm all but the brightest of all the meteors. So it's not something that I plan to get up before dawn and look for meteors with. So instead, let's talk about the moon a little bit. So the moon is going to actually reach its full phase at 10:45 GMT, which is the Greenwich Mean Time, on Thursday. And that translates to 6:45 a.m. in the Eastern Time Zone and 3:45 a.m. in the Pacific Time Zone in Canada. Now, everybody in the world sees the same phase of the moon at the same time. So if it's full for us in the Toronto area, it's full for everyone across Canada and around the world at the same time. And because the moon's going to be reach its full phase at about 6:45 in Toronto, that means that it's actually going to look full on Wednesday night and still look full on Thursday evening. But if you grab your binoculars and take a close look at the full moon, you're going to notice that on Wednesday night, the moon isn't quite waxed to its full phase yet. So it's going to have a little bit of darkness along its left hand or western limb. So you'll see some craters that show some shadows along the western curve of the moon on the Wednesday night. And then on the Thursday night, because it'll actually have passed full phase, that little dark strip of moon will actually jump over to the opposite limb of the moon. And now it'll be the right-hand strip or the eastern strip of the moon that has a little bit of darkness along the edge. The only people that are going to see the moon kind of rising when it's full, I believe, are sort of Australia, Southeast Asia. For them, the moon will be rising when it's full, and that'll give them that full effect. But for the rest of us, we get to see it when it's part full and part not. Now, the cool thing about the full moon is that everything you see on the full moon is caused by the moon's geology and not by the moon's topography. So normally when we're looking at the moon, we're seeing a dynamic, interesting terrain, we're actually seeing the result of shadows being cast by mountain peaks and crater rims. And because the moon has no atmosphere, there's no air to scatter the light. And so the shadows are deep, deep black. But at the full moon, all the light arriving at the moon is coming, say, basically from, if you're facing the full moon, all the light is arriving from the sun behind your head, kind of like the projector in a movie theater. And all that light is arriving straight onto the moon, so there's not actually any shadows being cast by anything. Everything's being lit from straight above. And so when you look at the moon and you're seeing the light areas and the dark areas, you're actually seeing differences in the rock types. So the light areas are a rock that's primarily composed of something called anorthosite, which is an aluminum-rich crystalline rock. And the bright reflection of that brightness that you're seeing is actually crystals of the rock that are reflecting the light back at us. Now, the dark patches are the lunar maria, and maria is the Latin word for sea, because long ago people thought that those were water features. We didn't have no telescopes to look it up, to view the moon up close. So from afar, it looked as if those dark areas might be oceans. And so we put the word mare on those, the Latin word for seas. And the mare are actually, many of them are sort of round in color. You can see sort of the round shape most of them have. And these are because the mare are actually giant impacts that blasted onto the moon early in its geological history and excavated basins or bowls into the moon's surface. And then later, the lava that was inside the hot interior of the moon welled up and flooded and filled in these basins, the deep basins, with dark, sort of iron-rich basalt. We have basalt on Earth as well. So if you go to Hawaii and look at the volcanoes in Hawaii, you're seeing the dark sort of crystally, or maybe rocks that have bubbles in them. Those are sort of the same basalt you get from that are in the mare. And as a result of the way that the mare formed, that means that the white rock is actually still underneath there. So you can actually have a layered effect where you have dark rock on top and white rock underneath. And so you get a few things that happen because of that. So some of the more recent craters on the moon, particularly this one, Tycho down here, this is a recent impact on the moon. When something blasted into the lunar highlands, the white area, and excavated Tycho, it blasted its debris across the moon for thousands of kilometers to produce these radial ray systems. And you can see that the white rock is actually overlaying some of the dark mare. So you're getting that effect, that contrast effect. And some of the lunar missions, some of the Apollo missions that went nowhere near Tycho still picked up material from Tycho that had been thrown far, far across the moon's surface. So these ray systems are everywhere. So you can look for, let me just bring up, I have another sheet of notes here. I just wanted to highlight here. And go here. So there's a ray system around Tycho. There's a ray system around Copernicus, which is sort of, rather than the straight streaks that you see, Copernicus tends to be a little more tattered and wiggly, the rays. So those are really neat to look in binoculars. Then you've got, let's see, we've got Kepler. So Kepler is another one. Then we've got over here, you've got this one called Proclus. And you can see that this crater here has a ray system that only encompasses a bit more than about 200 degrees of its circumference. So there are no rays on the western side, but only rays on the eastern side. And by the way, east and west on the moon, so north is up, south is down, and the moon is like looking at a map. So when you have a map with north up, then west is to the left and east is to the right. So this is the eastern part of the moon as we're looking at it. So Proclus, you can look for this asymmetric ray system. That's sort of the impactor that produced this crater came in from this side, slammed into the moon, and then threw all the debris ahead of it. So that's why you get an asymmetric system. There's a nice little one across the top of the moon. This is an Anaxagoras. And the more you look, the more you see them. They're all over the place, these ray systems.
And Chris, do you happen to know why Copernicus's rays are so wiggly?
It's partly to do with its age and the intervening history of the moon, but I don't have the geophysical explanation for why that is the case. But it's something that the lunar geophysics, lunar geology experts use to to understand the processes that happen on the moon. So that's one effect you can get. Now, Another thing you want to look at on the full moon is you notice that Mare Tranquillitatis, which is this one, is a darker bluer color than the ones next to it. Let me just bring up another picture of the moon here. I've got some labels. Here we go. So Mare Tranquillitatis, the red numerals here are the Apollo mission landing site. So here's where Apollo 11 was sent. It was chosen, this site was chosen because it was sort of near the equator of the moon. So they didn't have to worry about a lot of orbital complications. And it was chosen to go to the Mare Tranquillitatis because A, the mare are smoother and less risk of the lunar module tipping over when it landed on something rough. And also because the basalts that filled the basin were enriched in titanium, to give it that blue color. And so they wanted to understand the unique geology of Mare Tranquillitatis. So when you're looking at the moon visually of the next few nights, you want to look for the color differences, look for the ray systems, pull out your binoculars, and you'll see even more ray systems around some of the other features. And the other thing I want to show you that's really neat are the volcanoes on the moon. So some other effects that you get. Let me just bring up another picture here. So when you have the situation where you have the white rock underneath and the dark rock above it, sometimes an object can come in and punch a hole through the dark layer and then spew the white rock underneath it around and make a white halo around a dark crater. You can also get another situation where you've got a bright crater with a darker halo around it. You can get these different effects that happen. So let me just bring you a couple of close-up looks. Here's that Proclus. Here's where Proclus is. Here's another one. Here's a crater, a pair of craters called Messier. I'll just bring up the picture of Messier. So Messier are a pair of craters produced by a double impactor that came in on a very shallow angle, maybe as little as 4 degrees above horizontal, and came in from this way and through the material ahead of it, and it produced a double streaked ray that looks like a comet on the moon. So if you go back a little bit, so let me just go back, show you where that is, where to find it. So you want to look for, there's Mare Tranquillitatis, the blue one. So just cast your telescope or binoculars, probably a telescope's better. And right in the middle of this one, you can see the little streak. And that's the comet-shaped Comet Messier, after Charles Messier, the comet hunter. Yeah, let me give you another couple, and then we'll switch off.
That's such a cute idea, especially when again, it just looks like a comet. It's not necessarily an actual, it just looks like it. It's so cute.
Yeah. And it's really neat in a telescope, and it's particularly noticeable around the full moon because at that point, you're really seeing the contrast of the ray.
Cool.
This little crater Dionysius is a neat little white bottomed crater, but it has dark rays around it because now it's the Maria rocks that have been sprayed around it. So that's a sort of a contrast effect. And again, you want to see where that is. That's right at the bottom edge of Mare Tranquillitatis. So you can look for that bright white dot and zoom in on it and see the dark rays around it. Let's just jump, around Copernicus, which is that big crater in the middle of the moon. Let's go back a second. So around Copernicus with the wiggly rays, you zoom in on that patch of the moon, then you can look for dark craters as well as white craters. So again, these are the ones that are punched into the Mare material, and these are the ones that punched all the way through the Mare and then excavated the white rock underneath. So you can get these dark patches and dark craters and light craters. And you get craters with like white centers and dark halos and things like that. Plato was a crater and a Mare. It's been excavated into a circle, and Grimaldi as well. These two, they look like little mini Maria. Now, if you just sort of look around, you can see all these little white specks on the moon. So these are young craters that have been excavated and produced these white, unweathered systems, sort of fresh looking craters that give you these sort of white stars effect all over the moon to keep an eye out for. Let me just advance a little bit here. There's something I want to show you is the volcanoes. So this is a crater called Alphonsus, and these 3 dark patches that are quite easy to see in good binoculars or a backyard telescope are actually dormant volcanoes on the moon. And these dark stains are the cinder or the volcanic eruptions that have come and deposited the dark fresh material in the crater. So here's a view at full moon, and here's a view at kind of a partial moon where the sun is coming in from an angle. Let me just show you where that is again. That's Alphonsus. So the way I like to look at the moon is I see Wilma Flintstone's face. So here's her sort of curl above her forehead.
Oh.
And her hair, and then her ear, and this is her eye. Here's her smile. And she's wearing a pendant. And so this Alphonsus is just under her chin.
Wow.
And there's the 3 dots. See, 1, 2, 3. Those are the 3 dark patches. So it's quite obvious, even I don't know about naked eye, but certainly with binoculars, you can certainly pick it up and telescope.
That's cool. I've never heard anybody use Wilma's face as the moon.
I can't not see it ananymore.
Yeah, no, well, yeah, that's it for me now.
All right, let's see. Now, up here in this upper corner, so here's Tranquillitatis again. You want to go up to the sort of ultimate eastern edge of the moon. There's a crater called Atlas. And there are 2 more volcanic patches inside that one. And then right beside it, there's a crater called Hercules that has a fresh white bottom to it. So you can see this sort of black and white pattern. Let's go back again. So you can see there's Hercules and there's Atlas right beside it. So those 2 craters. So those are a couple of things that you can do with binoculars and with backyard telescopes during the week of the month where you've got the full moon to deal with and you can't see any of your nebulas and galaxies and things like that. I think that's about it. Oh,
we have, okay.
Go ahead. Well, last thing I'm going to say is that, as I mentioned with Tranquillitatis, the moon is not black and white. The moon has some tint, some color. And when you take a color photograph of the moon and enhance it, you can get some of that visible. And this is the crater Aristarchus, which is west of Copernicus. And this is the most colorful part of the near side of the moon. And astronomers think that this color might be due to radioactive elements. So this is one of the more radioactive places on the moon's surface, high in radon emissions, as you can see I've got here. What was your question?
Interesting. Okay, cool. There are 2 questions and they are related. And one of the people asking the questions just answered the second question. So we'll give it a try. I'll hand it over to you, Chris. First question is, have we ever found any of this moon? Oh, actually, no, they're not related. Sorry. Have we ever found any of this moon ejecta on Earth, considering how powerful these impacts must have been? Has it ever made it over to Earth?
Yes, we have moon meteorites on Earth, and we have Mars meteorites on Earth. And we should recruit one of our meteor expert friends on a future session and talk all about meteors and meteorites.
Yeah, there's some really knowledgeable people about meteors. We'll bear that in mind for future sessions.
That also means that there might be pieces of Earth on the moon that were rocks that were erupted and sent there. And it's much harder to do, but there could even be Earth rocks on Mars. Cool. And that brings us to panspermia and the ideas of life in the solar system. And that's another topic for another day.
That's another topic. Oh boy, big opening up big new ideas.
Hey.
Another question, which has been answered by Dan, but I'm sure that you can answer it as well. Based on the number of craters, the moon has had a lot of impact. Earth has not had as much. Why?
Oh, that's not true. Earth has had lots and lots of impact. It's just that on Earth, the impacts get erased. Mm-hmm. So there's no weather on the moon. There's no atmosphere on the moon. There's no water on the moon per se. I mean, liquid water. So there's nothing to wipe away the impacts the way we have on Earth. So on Earth, we have plate tectonics, which recycles our crust. And then we also have wind and water and rock weathering that actually erase the impacts. But there are lots of impacts around on Earth. There's the Barringer crater in Arizona that many people have been to. We have the Manicouagan crater in Quebec. That's the really cool sort of round lake that's in Quebec. That's an impact crater. And there's actually a lot of them. They're all over the place. And now that everybody is playing with Google Maps and Google Earth, we're discovering new impacts all the time. Because people are just looking at the imagery and finding it.
That's very cool. The satellite stuff helps a lot.
Yeah.
And then 2 questions that are the same. What would be an effective filter to provide some relief from the moon's glares or filter colors? So
the best approach to using the moon. So first of all, you don't need a big aperture telescope for the moon because it's already giving you so much light. You don't need to gather all that light. So you probably want to use your smaller telescope to look at the moon. But the trade-off there is that the big aperture telescope does give you more detail, more resolution, and more crispness of your image. So what you do then is you get yourself a moon filter. And this is just essentially crossed polarized pieces of glass that dim the moon. So you just screw this on the back of your eyepiece and it'll dim the brightness of the moon. The other trick, and we'll talk, I was going to mention this next week when we do telescopes, is that if you have a telescope that has a double cap and you can remove the center one, that's for looking at the moon.
Oh.
So you let less light into the telescope so the moon is not so blinding.
Very cool. Okay.
And this is a true story. I have friends that have brought their telescopes to my star parties, and when I go to help them and I yank the whole front off, they say, "I didn't know you could take that whole front off." And they were just taking off the little circle.
Oh no.
Yeah.
Oh, they've been missing out on so much light.
I'll be talking about that next week. This one down here, this is called a variable polarizing filter. And this is where the two pieces of polarized glass are independent. And as you twist this, you can actually make it completely transparent or completely opaque. And so depending on the moon is only partly bright or fully bright, you can dial up the amount of reduction in light.
Cool. And then one last question, and then we'll move on to double stars.
Yeah.
When was the last time there was an active volcano on the moon?
Oh, well, the jury's out. There's been a report in the news even very recently that somebody thought there was some evidence of something changing on the moon recently. And of course, geologists and astronomers, when we say recent, we also mean, millions of years rather than billions of years. So nobody's going to probably be able to go out and see or watch a volcano erupt on the moon. But there have been reports over the centuries, people have been looking at the moon with telescopes of, new bright areas being formed that might have been outgassing of material from the moon, that kind of thing. So it's a good excuse for looking at the moon. You might never know what you're going to discover.
Very cool. Neat that it's still changing. I say it like now is suddenly a time that everything needs to be static because we're here, but it's neat to see it changing in our timeline and not just in geological timescales. Yeah.
So I recommend that folks navigate over to my skylights this week because I talked about a lot of this in the skylights, and I even included that diagram of the moon's cool features. So just head over to astrogeo.ca skylights and you'll see the post for this week that covers the moon.
There's the link in the chat. And with that, we're going to hand it over to Blake, who is the most knowledgeable person that I know when it comes to double stars. And I'm looking forward to this because I don't actually know that much about double stars. So Blake, please enlighten.
And I've heard Blake before and he's great. So take it away.
Pressure's on. So can you hear me okay?
We can hear you and you are officially spotlighted so everyone can see you too.
Okay, and I just started sharing my screen, my slide. Thanks for having me. My name is Blake Nancro. I'm with the Toronto Centre. Been a member of RASC since 2007. So what is that? Almost 15 years now. So I'm going to talk about double stars, what they are, talk about some of the neat sort of benefits of looking at them. They're a light pollution killer, so that's kind of cool. Talk about where you can.
Oh, Blake, your microphone's still cutting out a little bit here and there.
Is it doing it again? So let me do something. This often sort of fixes this. So I'm going to switch to a different mic and then I'll come back. Okay,
sounds good. And in that time, I'm going to just briefly explain when Blake mentioned that they're a light pollution killer. They're really nice for light polluted areas because they're so bright. We're not looking at something like a galaxy that's really, really dim or a cloud of dust and gas that might be a little bit harder to see when there's so much light bouncing around the atmosphere. They're going to be bright no matter what. They're stars. And so you can always see the double stars, even if you're in a city.
Okay, so hopefully my audio is back and hopefully it's better, cleaner. now.
I'll let you know if it cuts out again, but for now you're good.
Yeah, thanks. So moving on here. So a little bit of terminology before we get too far into this, because it can be confusing. There's lots of different terms that you'll hear people say when referring to double stars. If I phoned you up and said, hey, you want to go observe some double stars, multi-star systems, binaries, triples, quadruples, and a few quinviginupal star systems tonight, you'd probably hang up on me, go, I don't know who that was. You know, a lot of times we want to see double stars or multiple stars. I was in a quandary when I was first getting into these seriously, because it just seemed like two wasn't the right word, because there's a lot of triples and there's a lot of quadruple systems. But it's widely accepted that we use the term double star to refer to any type of system. And it could have 3, 4, 10 stars in it. But we use this term loosely, double star, to refer to all of these. So I'm going to try to stick with that terminology just because it's less of a mouthful. What are double stars really? In general, it's any star that, or group of stars that are just tantalizingly, compellingly close together. They're intriguing, they're eye-catching. If you were just panning with your telescope or sweeping the sky with your binoculars and there were two stars really close together, you'd probably hit the brakes. You go, whoa, what's that? You'd have a look. And if you do get interested in them, you start diving into them deep. You go, are they the same color? Are they the same brightnesses? So it's usually kind of striking when you get two stars that are very similar, really close together. And it often begs the question, are they related? And we'll talk about that some more. But I get that question all the time at star parties. Hey, these two stars, are they related? Are they part of a system? We don't know. We don't know for sure. In fact, you have to study double stars for a long time. You have to revisit them. You have to take repeated measurements to see what's happening, if they're moving. So you could get this. Double stars might be just a simple chance alignment, random alignment of two stars that are very far apart in space. Let's say from the Earth, you're down at the bottom, right? That the star A is, I don't know, 1,000 light years away. Let's make it 10,000 light years away. And then star B is double that. It's 20,000 light years away. We're talking about stars that are now in kind of different parts of the galaxy. Maybe one's in our arm, one's in another arm of the galaxy. But when we look at them through the telescope, looks like they're together. Now we have to study those and do some research to see if they're moving and shifting in space. But this type of system where there's two stars really far apart, they're clearly not related. Okay, you could say that everything in the galaxy is related. It's all orbiting the central core and so on. But in general, these stars aren't affecting one another to the same degree that star A is not affecting things in the solar system or affecting the moon in a really direct way. The effects are negligible. Let's call it zero. So we call these optical doubles. Some people say, don't bother looking at these. They're of no scientific value. They don't mean anything. They don't tell us about star formation and so on. But I like looking at them because they're cool. You get some really great colors. They're interesting visually and so on. So I'm not picky. I don't discriminate here. Now, you can get stars that are really close together. Let's say those two stars that I'm showing are far from the Earth again. Let's say they're 10,000 light years from the Earth, but to each other, let's say they're only 1 light year apart. So they're very close in space together, and they are probably born out of the same material. They were born at the same time. They're like a family, and they move through space like dolphins in a pod. They're shifting together over time, and if we monitor them, we see their position changes slowly over time. Did you see that? I'll do it again. So they're shifting and moving slowly over time, and we can measure that, but we see, hey, they're staying the same distance away from one another. Their angle to each other is the same. So that type of system, we say that they're physically related. If they're 1 light year apart, they're not physically connected here, but we call them physical systems because there's some gravitational effect. And there's lots of groups of stars that move through space together. In fact, a good portion of the stars in the Big Dipper are part of a group or a family. When you get stars that are really close together, these are a very special type of a physical system, but you can get stars that orbit one another. And the distances between these stars might be, we shift to a smaller unit, one that you may know from the solar system, that we have things that are astronomical units apart. I think Chris talked about that an astronomical unit is the average distance of the sun from the Earth. And Jenna or Chris, correct me if I'm wrong, I think Neptune is 22 astronomical units away from the sun, and I think Jupiter is around 9 or 10. So if we get stars that are 50 astronomical units away, that's kind of like where the Oort cloud is in our solar system. They can be closer, they can be further away, but then you get a star orbiting another star, like a planet in a solar system. And maybe 10 years from now, when you look at that star, let's say initially, this is what we see in our telescope on the right, and the star is sort of in the foreground. And then 10 years later, there's a slight change in the position of the B star in relation to the A star. In our telescope, I'm showing the old and the new positions. Now, at first, we might go, oh, the B star is just swinging by, it's drifting by the other star. But then we look at it 10 years later, again, now it's 20 years of time, and we start to see that it's in a curved path. As soon as we start getting a curved path detectable, and relatively few observations are needed to do that, this is of great interest scientifically. Now we've got a star orbiting around another star, and that's a binary system. And you know what? You can measure this in your backyard. High school students and college students, they get together and they measure double stars, and they report the positions of the double stars, what the angle and the separation is from one another. And you do repeated measurements, and you can submit that data. Anybody can do it. I've submitted a paper to the Journal of Double Star Observers, the JDSO. So you and I can do this. And this is really important when we get the orbital data of two stars, then we can get the mass of the system, and then we can get the mass of the individual stars. And the mass data, when it's known for stars and then used with other data about stars like the stellar class and so on, this helps us with, this is a cornerstone in scientific measurement of stars. We can fairly accurately calculate distances, and it's all part of the cosmic ladder that we use for calculating distances. Some people do variable star measurement, and again, that's easy to do. Backyard astronomy, citizen science, and they can contribute in an equal way. It helps us learn data about stars. But this is cool stuff that you could do. Watch some double stars and send in your orbit data. So this makes for just an enormous array of different double stars that we've got all kinds of different colors. We've got all kinds of different groupings. Here we have a pair of stars really close together, attractively close. Here you get amazing colors. Can you see the orange and kind of beige stars are quite far apart. They're easy to see, widely separated. Now this one, can you see it?
Really it's tiny.
See the tiny little baby? It looks like a planet orbiting around a star, but that's a dim star to a bright primary. And that can make for some challenging observing. Sometimes if you don't have good conditions, you can't see that little dim star. This is why I like looking at double stars. You get all kinds of colors, all kinds of patterns, all kinds of arrangements. Some of them are easy, some of them are challenging, and some of them change over time. They're like gemstones in the sky. And as Jenna mentioned, you can look at these kind of any time, anywhere. You don't need equipment. You can look at double stars with just your eyes. There's a couple of dozen double stars that you can see. I'm assuming you have an eye or two good eyes or good eyeglasses or a good prescription. So now you can see some double stars. And I've listed some examples there. Alcor and Mizar and the Big Dipper, pretty famous example that people can see. I've listed 3 stars in Cygnus, 30, 31, 32. 2 of those are really easy to see, and then one of them's really close to the other one. So you might not be able to see all 3 unless you get the binoculars out. But Omega 1 and 2 in Scorpii is super easy to see. That'll be a good summer target. And that reminds me to remind you that if you look in the RASC Observer's Handbook, in the first essay that's about double stars, it starts off saying that 85% of the 85% of the stars that we look at just with our eyes, or initially think as a single star with binoculars, are in fact doubles or multi-star systems. So 85% of the stars that you would look up at and see in the night sky are in fact doubles, triples, quadruples, and so on.
Wow.
And there's a couple in this picture. This is winter time, so this is Orion and the Pleiades and Taurus. So maybe you can't see those right now, but next winter, have a go at those. See if you can spot those double stars with just your eyeballs. There's a few of those that I can see when I've got my eyeglasses on. If you're using binoculars, now you're into thousands of targets that you can see. There's different opinions about whether you should mount your binoculars. If you do have them mounted on a tripod or on a parallelogram or a neat contraption with a tripod, that gets the binoculars steady. But an advantage to binoculars is that you can move freely. You can look anywhere in the sky. So if you're going to handhold your binoculars, learn some tricks for getting them really steady, or lean up against a building if you need to. Again, I've shown you a few nice examples that you can see with double stars. I'm going to simulate some of the views in Stellarium in a moment, what we can see with our eye, what we see with binoculars, and what we can see in a telescope. And here's some telescope targets now, just a handful, but we're into the tens of thousands of double stars that you can see, enough for a lifetime. You can't run out. I've been seriously observing double stars for 7-8 years, and I've seen over 1,500, or I've split 1,500 pairs. So lots of great double stars out there, again, from easy through challenging. And remember, that's that 85% that I was talking about before, that we look at a single star and we go, oh, it's just one. And then you put binoculars on it, you go, I think that's 2. And then you use your telescope one time on that same target and you go, it's definitely 2 stars. Hey, there's another one, it's a triple. So that happens all the time. Remember I talked about Alcor and Mizar that you can see with your eye? Go back and look at it with your telescope. I'm not going to say anything more. So let me do a little demo in Stellarium here, and I'll show you the whole sky, and then we'll simulate views in binoculars and then in a telescope here. So Stellarium's up and running here. Hopefully you can see my screen okay. And as Chris showed us, we can advance time very easily. Let me turn to the west. So I'll just let the sun go down, and there's the moon's way over there, and Venus is just setting. I'll turn on the cardinal points so we can see our directions, and I'm going to turn around to the north, here, and I'll turn on the constellation lines. And I'm looking north. You can see the Little Dipper and the Big Dipper. There's the Big Bear and the Little Bear and all the other constellations. And I've emphasized just the asterisms, the Big Dipper here. Now I'm going to do something. I'm going to zoom in a little bit. I'm just using my mouse and the roller to zoom in. You could use your page up, page down keys in Stellarium. Down at the bottom of the screen, do you see this? Do you see FOV? That's field of view. That's how much of the sky from top to bottom edge of the screen you're seeing. So I'm at 43 degrees. Now I'm at 50. Back in a bit. I'm too close at 36. I don't know, at around 40, 45, 43. That feels like to me what the sky looks like if I'm looking at it with just my eyes, roughly. So do you see it? Do you see the double star that you can see with just your eyes? So we know that down at the end of the pot, we have Dubhe and Merak and so on in the Big Dipper. And there's Alkaid, end of the handle of the Big Dipper. But if we come in one jump, one hop from the end of the handle, there's Mizar. And then right beside Mizar is a little point of light. Do you see it? That's Alcor. So there's Mizar and Alcor. I'll cheat. I'll zoom in a bit. See, two stars.
Oh yeah.
And if you look closely, Stellarium simulates. It tries to accurately simulate color based on stellar class. So one of those looks to me kind of yellowy, and the other one's kind of blue. Oh look, there's another star, a little faint star in there. That's not officially part of it, but some people say, oh, I can see 3 stars in there who have very acute vision. So if I go back out to about 43 degrees, that's kind of what you can see in the sky. There's a naked eye double star. So that's kind of nice.
Hey,
yeah, question?
A couple folks have asked about that being used as an eye test, either by the Romans or optometrists. Is that something, do you know about that?
Yeah, I've often quoted that story, but I've never sort of researched if it's true. But certainly it is a good eye test for anybody. If you can split those 2 stars, you've got sort of average vision. The late Patrick, Chris, help me out, from the UK.
Patrick Moore?
Patrick Moore made the Caldwell list. He said people with above average vision, better than 20/20, could see that dim star between Mizar and Alcor, naked eye.
Wow.
I've never been able to see that. I don't have vision that good, but I know people that have better than 20/20, and they can split tighter sort of double stars. Huh. If I head to Omega in Scorpia, so do our find command in Stellarium, and I'll use the Greek letters down at the bottom. There's Omega, Scorpii. So we'll head there. Of course, it's a little low right now, but let me just advance time a little bit, just so it gets a bit higher in the sky. There we go. And there's the Scorpion, right? There's the constellation. There's the eye of the Scorpion and one of the pincers going up towards Libra. And do you see it? See it? In the top star underneath Beta is Scorpio, Omega 1 and 2. So easy to see. I'll zoom in. You can see them easily. Nice pair of naked eye double stars. Easy to see. That's a great summer target. Now, if I keep zooming in, if I zoom in some more, actually, I'm going to use some keyboard shortcuts. I don't know if these work for people on the Mac environment, but for Windows, I'm going to hold down Control and Alt keys. When I press Control Alt 1, it zooms me out to 180 degree field of view. Control Alt 2, 90 degrees, then 40, 60, and 45, and so on. I'm going to do Control Alt 7. That's a 5 degree field of view, top to bottom. And now when I look at Omega 1 and 2 in Scorpius, I go, yeah, whatever. It's just two stars in the sky. So if you use binoculars on these stars in Scorpius, they might not look special. There's a magic number. You need stars really close together. These are a bit more interesting over here. Do you see these two dimmer tight star? That might be a double star system. This little grouping here, that's sort of tantalizing. So when you're using binoculars, of course, you're magnifying everything. Everything gets bigger as if you're drawing it closer. And you also increase the distance between stars. That's what splitting is all about. Now I'm going to use another special feature in Stellarium. I'm going to go to the ocular view. I don't know if you have the ocular plugin enabled. It has binocular eyepiece settings and telescope settings. And I'm going to switch quickly through the ocular settings till I get to the Celestron 15 by 70 binoculars. So these are fairly big binoculars, 15 times magnification. You can see the field of view is a little smaller. It's 4 degrees. But there's Scorpia. Oop, there's Omega 1 and 2 Scorpius. Again, they don't look like anything sort of special, but I'm going to just move down. I'll just pan down here, and Antares is around here somewhere. I'm getting close. There it is. There's Antares, nice bright star. And there's a neat sort of double over there. There's Iota, Scorpii. And that's neat. Look at those little group of stars up there. That's pretty cool. And that's Rho. That's the Rho star, and a couple of stars really, really close to that. So now you can see there's a lot more stars that are visible in binoculars, or sort of tantalizing here, because they're again, those stars are that right sort of distance apart from one another. Now I'm going to go to Alkalurops in Bootes. One of the stars in Bootes, and there it is. Can you see it?
Yeah.
You see that double? So a nice double star there. They look like kind of gold colored stars to me. So there's lots of doubles that you can look at with just binoculars, and maybe put them on a tripod and aim at a particular constellation to soak in some of the doubles there. Now we'll zoom into a telescopic view for a double star. I'm going to change the ocular again. Now I've maybe got some ones that you don't have programmed into yours. So I've set to a Celestron 26 millimeter eyepiece, and I'm going to put it in an 8-inch telescope, an 8-inch Schmidt-Cassegrain 2-meter telescope. And now you can see Alkalurops is like super wide apart now, easy to see. I'm going to head to Albireo. That's our famous, very popular double star. Lots of people really like this, sort of beautiful colors and so on. And there's what it looks like, or sort of looks like, in a telescopic view. Now, I don't know about you, but I find when I look at that through my telescope, I can cleanly see two stars. But do you see they're kind of mushed together? So you get that in the real world with double stars. You'll get double stars that are so close together, and there's a really bright one and a dim one, that they smush together. They're blended together, or they merge. So you can increase the magnification. But part of it is here in Stellarium that Stellarium settings out of the box aren't quite ideal. So what I do often in Stellarium is I go to the Sky View settings, I go to the Sky tab, I go to the stars, and I drop the absolute scale down. It's normally 1. If I put it back to 1, you'll see the stars just blob together. But if you set the settings to 0.5, 0.6, you get a more realistic view as to what you see in a telescope. And now you can see they're kind of notched there, couple of stars. If I simulate that I'm using a much more powerful eyepiece, a 9 millimeter eyepiece, boom, double stars, and again, different colors there. So that's showing you what you can see with a telescopic view. One more in Stellarium here. We'll go to Epsilon Lyrae, which some people know is the double-double. So here I am with a high-power eyepiece in a 2-meter telescope 2-meter long focal length telescope with high magnification, but I can't quite see anything special, just like two stars. Again, I think if you look at that through a telescope with that power, you'll have no problem seeing that. In fact, these are two sets of stars. There's pairs here, 2 pairs, the double. Let me get out of ocular view and let me just zoom way back in, really close to these stars. And once again, I'll adjust my settings here. I'll drop it down to 0.6 or 0.5. And you see what happened? We have 2 pairs of stars and they're opposed at a 90-degree angle to one another. You'll easily see that at high power in your telescope, the double. So that's kind of cool.
And Blake, you don't need a big telescope. No,
it's true. 6-inch telescope, 3-inch telescope. It's just maybe you need magnification of around 100 times 100 power or more to get those, and good conditions. Steady air. You don't need a dark sky. You need steady air conditions. So that was a quick sort of look that in Stellarium and lots of the other software tools that are very popular, when you zoom into a single star, the zooming in is the equivalent to you putting higher power eyepieces in your telescope. Then you see, hey, that's not 1 star, it's 2 stars. You're splitting them. So that's cool. A couple of closing notes. Couple of closing notes. Do you have to go to a dark sky location? Do you have to drive for 2 hours to get out of the city? No. Yay. We don't need to be in a super dark sky location. You can do double star observing in your backyard. You can do it in your driveway. Probably you don't want to do it out on the sidewalk right now because you'll get people want to have a look and you'll have to tell them, hey, stand 2 meters back. But the point is you can view double stars anywhere, anytime, even if the moon's out. And as Jenna pointed out, that's because star light is this tightly concentrated beam of light that can punch through light pollution. If your neighbors don't turn off their lights, if there's a really bright street light nearby, you can probably still easily see lots and lots of double stars. So I encourage you to just sort of get out there and run what you brung. You don't need, again, special equipment. Where you can get a list, once again, the RASC Observer's Handbook, it has 2. All the astronomy magazines have double star information. Sky and Telescope, both their magazines and their website are very, very good for double star information. The Astronomical League in the US, they have binocular and telescopic double star lists, so that's good. The Evening Sky Map, I don't know if this has been mentioned at all, but this is a great little free printout that you can make, and it shows you what the sky looks like this evening overhead, gives you some targets that you can chase after. But what I really like about the Evening Sky Map report is that they show what is visible to your eye, to your in binoculars or in a telescope. It's nicely broken down that way. But kind of probably the number 1 most popular book on double stars is by Sissy Haas. And you can see the title there, Double Stars for Small Telescopes. Literally 3, 4, 5-inch diameter telescopes is fine, is sufficient. And she has over 2,000 entries in that book. So again, that's really popular. Your existing paper atlases, if you have them, if you look closely, you might see that there are stars that look like a lollipop. That have a little stick through it, or a martini olive. And that's an indication of double stars. If you use planing software, I use lots of planing tools. They can list double stars and tell me about their viability, if they're going to be splittable or not. And in your controller of your go-to telescope, there might be a subcategory for double stars with a bunch of showpiece objects in it. So I hope this has given you a sense of what double stars are, that they're fun, they're colorful, that a lot of them bear repeat viewing or a deeper dive. You can look at them any night when it's clear out, but the silly moon is flooding my backyard. I still go out and do double star observing. So again, you can do it anywhere, anytime, and you really don't need any special equipment. But if you do get a telescope at some point and you want to revisit some of those double stars that were interesting, you might find, hey, it's a triple. And they're real crowd pleasers at star parties as well. I don't know what it is, but a lot of times double stars get overlooked, and people go for star parties. They go after challenging targets like galaxies that are dim and faint, and to serious amateurs, they go, oh, look at that galaxy, that's so cool. And a novice is looking through the eyepiece going, I don't see anything, it looks like a cloud. It's like a cloud to me. So show them a double star and they'll go, wow, look at those colors. So low-hanging fruit.
The colors are really cool to be able to see such different colors in two different stars so close together.
I like to get everybody to think about what colors they see, but not say. And then once everybody's had their turn to reveal what the group consensus is.
Thanks for saying it that way too, because when you look through the telescope, your first impression of a star field is, oh, there's a bunch of white stars. But that's another interesting thing about double stars. When two stars are drawn close together, then it becomes more apparent that they are not the same color, that they have subtle hues or tints to them. You might think, oh, there's two white stars, and then you look closely and you go, no, one of those is blue and the other one's a little bit orange. So the colors become more apparent when stars are close together. A bit of shameless self-promotion. Check out my blog. I've got lots of articles about double stars. I recently did analysis of the Xi Ursa Majoris star that I've been looking at for 10 years, and it's been moving. It's moved about 45 degrees since I first started viewing it. An incredible website is Bruce MacEvoy's website. Now, this is a bit more technical, but for hardcore serious observers, this is an amazing resource. And he talks about how to train your eye to see double stars. It takes some practice. I mentioned the Double Star Observers Journal before, the JDSO. The official source for double stars is in a database called the Washington Double Star Catalog. And this is maintained by the U.S. Naval Office. It's currently accessible at the Georgia State University. And there's over 150,000 double stars in that database. And I don't know the exact number right now, but only about 25% of them are known to be binaries. And most of them, we don't have very much data on it. You with me? Data is needed. So citizen scientists like you and me, we can add to the missing information to this database or everywhere. Hey, that's Chris. And I just pointed to Cassiopeia, and there's a ton of cool double stars in there. So thanks for your time. Get out there, even if the moon's out. Happy splitting, and I hope you enjoy looking at double stars. I'm happy to take questions.
That's amazing, Blake. That's so cool. Honestly, I've seen a couple double stars at star parties, but I've never really dove into it. And so it's really cool to be hearing so many amazing things about it. And it's so cool that there's so much room for citizens and for non-scientists or amateurs to be able to help out.
Yeah. Hey, Blake, would you mind using Stellarium and just bring up Lyra and just point out all the doubles on the corners of the boxes and things like that? That's easy for people to navigate.
I'm still on the double there, and I'm zooming out, as you can see in Stellarium, and
just put some labels.
You can see, hey, there's the double near the top there that we were just looking at, and this is maybe, again, I'm at a 5-degree field, so that's sort of what you see in binoculars. It's very eye-catching. But what Chris was talking about.
Before you go though, Blake, that's about one finger width. That triangle with Vega and the double, right, it's about one finger fits.
Yeah.
Okay.
So it's kind of easy to pick it out that way. Sure.
And then a very neat system is over here at Delta. So Delta, it's showing as Delta 2 in Lyra, but if we zoom in there, and I'll just get rid of the labels for a moment, you can see there's lots of stuff going on in here. So there's lots of stars just in that area, and Delta itself, I thought it was a super tight double, but anyway, there's some good stars nearby. There's the Delta 1 and there's the Delta 2. That's a good telescope object. And then down at the other corner, if we're heading towards the bottom, I'd mentioned Sulfat in my list. That's Gamma Lyrae. And we'll zoom into this one. I'm simulating a telescope view. And again, we can see that other stars start moving away and they become easier to split. There's the Ring Nebula. We're just a short jump away from that, of course.
Oh yeah.
So yeah, there's quite a few doubles in the Lyra constellation, and there's other ones that people sort of advocate, say, hey, this should be another double.
Get that one in the middle there.
Yeah.
Yeah.
So right there. There's a nice one, and again some different colors, yellow and blue, and see it's splitting.
Oh yeah.
So this is just simulating. I'm going to much higher sort of magnification. That, hey, it looks like a triple little hockey stick kind of thing. So you get neat sort of patterns when there's more than two stars there.
Very cool. We don't have, you covered everything spectacularly. The only question that I had was, I know a while ago in like popular science, so not necessarily good science, there was some talk about our star having been at some point a double star and we lost its partner, or maybe that its partner was Jupiter and it never grew to the right size to be a star. It kind of stopped part way. Do you know anything about that?
So I think this is some of the information that it's a good question in the sense that there's a lot more information that's needed. I don't think there's a definitive answer one way or another. We know that the closest stars are in Centaurus, right? Alpha and Beta and so on. And we know how far away those are. They're just 4, 5, 8 light years away. So were they part of the same family, and that our star was part of that? Maybe. So I don't think there's definitive information. There's probably research papers being written by grad students right now debating this one way or the other. So it's difficult to determine, but some of the recent surveys that are going on, for example, the Gaia satellite by the ESA, the European Space Agency, has been doing fantastic studies of millions of stars and then plotting the change in position over time, and then extrapolating that data forwards and backwards in time to figure out where they came from and where they're going. And that kind of information might be feeding into papers saying, hey, it looks like now that this group of stars, and we're moving with them, are all heading in this direction. So that might strengthen the argument that the Earth was part of a multi-star system. Bruce MacEvoy, who I mentioned, his handprint website with that fantastic double star information, that he's very passionate about this, that the study of double star research is very important because it tells us extraordinary information about the formation of star systems, and that star systems are often formed in hierarchies, or there are hierarchical arrangements of systems. So that double star research, again, needs to be done. We need to get more data about pairs of stars, and when we get doubles, and it's the two pairs orbiting each other, and then the wider pair orbiting each other. These are hierarchical systems that are stable. Triples, not so much maybe, but you can get a double, a pair orbiting a single. So we can get various different types of stable hierarchies So this is sort of very deep research and scientific work that people can do with double stars. But again, I don't think we know a lot of information for certain about what happened with the sun.
For sure. Okay, cool. Thank you very much for your time and for that presentation. I'm really excited to go out and, you know, being stuck in a city right now, being able to still go out and do stuff.
Woo! More double stars for everybody.
That's awesome. Okay, so we have decided to extend our sessions as mentioned a couple sessions ago. So we're going to run till 5 o'clock today, which means that Chris is going to enlighten us with some other binocular targets. We have plenty of homework. Oh, I have to remember to there we go. We have plenty of homework to go and look at double stars, and I'm really excited. I've sent out the list of the double stars that Blake was talking about in the various types. So naked eye, binoculars, and telescopes. They're in the chat. And they're also in the description of the YouTube video, for which I sent out the link as well. So if you guys want to give those a search on stellarium and planar observing sessions, they're there and ready. Thanks again, Blake. Now over to you, Chris.
Yeah, so what I'll do is I'll highlight a few of the things that folks can head out and look at with binoculars, both while the moon is up, but even, you know, when the moon clears away. So the moon will be kind of rising at sunset, which is late this time of year. On Thursday, because the full moon rises with the sun. But within 2 or 3 nights, so by the time we get to the weekend, Sunday night, Monday night, the moon will be rising quite late. It'll be waxing a little bit. So we'll be getting back into a fairly darker sky. So I'll point out a few things that you can use this week. Don't forget to look at Venus. Venus is so pretty right now. I looked at it last night with my telescope. I'll just zoom in on Venus. Every night it gets a little more delicate in its crescent, and it's really gorgeous. So if you've got a telescope, dust it off and take a look at Venus. It's very easy to find, and it's well worth seeing. All right, so while we've got the western sky, I've got the western sky here at about 9:30 p.m. So it's not quite dark yet, and it's not maybe too late for the kids to be up. Not that there's school tomorrow, but you know what I mean. Mm-hmm. Take a look at Pollux and Castor. So Pollux and Castor are the 2 fairly large, fairly bright stars that are higher than Venus, but in the same western sky. And Blake didn't mention this one, but it's certainly one of his recommendations, I'm sure, is that if you zoom your telescope in on Castor, you'll discover that it's a relatively easy double. And I'm going to do that trick of reducing the size of the stars. Oops, wrong one. Here we go. Stars, this one. Drop this down to around 60 or so. So Castor is a fairly easy to see double star this time of the year. And it's bright, easy to find. Let me just pull back a little bit. So Blake mentioned sky maps, skymaps.com. I'm just going to bring a picture of the Sky Maps handout. So every month, the creator of this website generates this printable handout that you can take outside. It's got a star map for the evening sky, and then it's got events that are happening during the month. And if you swing down to the back side, the second page, he's got a list of objects that are easy to see with your naked eye, and then binocular objects, and then telescope objects. I'm just going to highlight some of the binocular objects for us, as I mentioned. Now, again, with the moon up, it's going to be a little bit harder to see, but if you can cast your gaze a little bit to the left of Castor and Pollux, I'll just measure this off a little bit. It's about 1.5 fist diameters to the left of Castor and Pollux. You can find this cluster. So the big yellow dotted circle here represents a deep sky object, which is an open cluster. This is the Beehive, or Messier 44. And you'll probably pick up several dozen stars fairly easy with the moon and the bright moon in the sky, and then even more stars once the moon clears out of the way. So that's the Beehive cluster. And it's in the west, so it's not kind of an all-night target, but it's something you can take a look at with binoculars and certainly with telescopes. If you want to see it in your telescope, make sure you use your lowest power eyepiece. You're the one with the biggest number on it, and that'll give you your widest field of view because it's quite large in size and it'll spill out beyond your telescope's view. if you magnify it too much. Now, back up here in our galaxy hole, this is where all the galaxies were to be found when we talked about galaxies a few weeks ago. And I mentioned, I think at the time, that if you look for this constellation of Coma Berenices, it's kind of an L-shaped constellation. The stars aren't very bright, so with the moon nearby, they're going to be hard to see them, but you can certainly navigate by starting at Arcturus and sort of sweeping with your binoculars up to the right a little bit. And look here, so this is about 3 fists diameters held at arm's length. You're going to find what's an object that's called Malot 111. And Malot was a gentleman that was looking at star clusters, and he recognized that this star, there's a patch of stars just off the edge of Coma Berenices. This would represent kind of the ponytail of Coma Berenices, because Coma Berenices is Latin for Berenice's hair. And this patch of stars would be relatively easy to see in your binoculars, especially in a few nights hence when the moon clears out of the sky.
Just a quick question from, Blake has already answered it. What minimum power binoculars do you need? And he said about 7 times. Does that fit with your thoughts, Chris? Yeah,
so really any magnification will work nicely on most of these targets. But if you want to see the ones that are competing with the moon, then you want ones that have a bigger objective lens. So you want your 7 by 50s or something in that range for astronomy. If you've got the little opera glasses, you can see these targets, but you'll get more out of them if you use a bigger pair.
Thank you.
Let's see what else can we find out here. So over here in the eastern sky, we've got some of our summer delights starting to rise. And one of the things you want to look out for, well, are these symbols that have the circle with a cross through them. And these are globular star clusters. And what's nice about these objects is that the stars are so tightly packed together that they're visible from light polluted skies in a telescope particularly. You can certainly see them in binoculars once the moon clears out of the sky, but if you've got a go-to telescope or you can wait till the moon makes your sky a little darker, you can start looking at these objects. There's one back here. Yeah, there's one up here called Messier 3, again up near our friend Berenice's hair. And it's right above Arcturus. So if you take your binoculars and scan upwards from the bright star Arcturus by about 1 fist diameter with your binoculars. So your binoculars are going to cover an area of sky about that big. And if we zoom in, just put it in the middle and magnify it for you. Now we get rid of the symbol.
Ooh.
You can see this starburst. So that's a globular star cluster. You're looking at hundreds of thousands, if not millions of stars, all concentrated into a sphere by their mutual gravity. And it looks a bit like salt or sand or sugar spilled on a black tablecloth. So this is called Messier number 3. This is, its brightness is about 6.2. So if you're using stellarium, you want to look for the ones that have magnitude numbers that are lower, the lower the better. So magnitude 6 in that range is very good. So that's that one. And I'll show you another one that's easy to find. Let's put my symbols back on here. There's another one down here near the bottom edge of Coma Berenices. That's Messier 53. So that's a 7.7. It's a bit bigger, a bit dimmer. You can see you get a 2 for 1. There's actually 2 of them in this patch of the sky. I'll just turn this off so you can see them.
Oh, wow.
Yeah, it's there. But the real showpiece for us in the summertime gets a little higher later, and it's down here. Let me just wind back. And that's down here. You want to look for Hercules. So let me just get the sky a little bit darker, and Hercules will get a little higher. So this is getting closer to 10 o'clock. So you can look for the sort of circle of stars, which is Corona Borealis. And then look to the lower left of that. You're going to see the bright star Vega. That's where the double is, and the stars that Blake was showing in his presentation. But Hercules is distinguishable by this really neat keystone-shaped asterism. So keystone is 4-sided figure with one short end and one long end. If you look for the keystone shape, then you want to look at the high side and go 1/3, 2/3. You want to go about 1/3 of the way from the top, from the wide end, 2/3 from the bottom end, and magnify this object called Messier 13. And you can see the magnitude of this is 5.8, so it's brighter than M3 that I talked about a moment ago. And this is definitely a good binocular target, especially when the moon clears out. And what I can do here is I'm going to bring up this digital sky survey. So let me just switch off that one and show you what it really looks like without the stellarium stars sort of overlaid on top of it. So it's actually quite large. And that's Messier 13, or we call that the Hercules globular cluster. Let's put on the stars back again. That's our time here. Any more questions come in yet?
Yes, we do have a couple questions.
Okay.
The first question is, how do astronomers actually find what they're looking for, or what piece of the sky they're looking at?
Well, first of all, folks like Charles Messier, William Herschel, they actually engaged in campaigns of searching the sky. So especially William Herschel, he actually swept the sky row by row by row by row over years and years, and discovered all of these little faint objects and noted them into catalogs. And so now we have books, thousands of these objects that are in the sky.
So
you can use an app. So astronomy app like Stellarium, which will show you the symbols of where they are, or you can use a star catalog that has symbols where those objects are. Is that sort of what you're?
yeah, and like I was thinking, the only way that I can ever figure this stuff out, apps are okay, but I have a hard time with them sometimes. It's just by star hopping. So I start on I almost always start at the Big Dipper and go from there, and then try to find a bright star, and then hop from that bright star to the next bright star until you get to where you're going for.
As Blake sort of suggested, he showed you the asterisms. These are these easy to recognize star patterns that we use to navigate ourselves, especially in a light polluted sky where we have fewer stars to play with. The bigger, brighter ones tend to form these easy to navigate patterns. So we do that. But you can just
wondered. Sorry,
ahead,
Chris, to interrupt. I'd wondered if the question was a little bit about how, from a recognition point of view, how do you know what part of the sky you're looking at? So, so if that's sort of the angle of the question, that to me that's a little difficult to answer. But the short answer is experience, and I think it's rooted for many of us in learning the constellations. So learning the constellations helps you, like if you were reading a street map, figure out the general areas that you want to go. From city to city, you need to know how to read a map. So I learned constellations and some of the bright stars in the constellation. So now when I look up at the sky, I can sort of get my bearings fairly quickly. Oh, I'm facing this direction. There's that constellation over there. Oh, there's Hercules. Oh, I know what's in Hercules. So that it's experience and it builds up over time.
Absolutely. Yeah. It's like knowing it's like looking at a map, except the map is on the sky. I found, this is minor personal anecdote, I promise it'll be short. I went for a walk last night, and I recommend going for walks at night. There's like nobody outside, and it's really easy to socially distance, and you get the chance to look at the stars. And I spent most of my walk tripping over my own feet because I was looking up and going, okay, there's the Big Dipper, and then we hop down to Arcturus, and then there's Spica, and then there's Denebula. Okay, so that's Leo, and so it's just a lot of like sitting and practicing, especially since the stars change each season. It's nice to do it, once a month sort of thing.
Yeah, and because the sky changes every month, then you sort of get to know these constellations are leaving and these ones are joining us. So here's a cool thing you can do with Polaris, the North Star. So the easy way to find Polaris is to use the Big Dipper and use Dubhe and Merak to point towards Polaris, and that'll be over the northern horizon. It'll be the altitude of Polaris will be equal to your latitude on the Earth. So for Toronto, it's about 43 degrees up. So Polaris is sort of, it's not alone, but it doesn't have very many bright stars around it. So you can generally pick it out pretty easily. If you then put Polaris in your telescope you can find out that Polaris, let me just turn off the, there we go. Polaris is actually a double star. So it has this little star, HIP 7283. And because as the Earth rotates, the sky revolves around Polaris, and this little companion revolves around Polaris through the course of hour by hour. So it's fun to sort of look at, depending on the angle of Polaris, where that star is. Basically, it's at a 90-degree angle from the rest of the Little Dipper's handle. And the other neat thing is, I don't know if you can see on the screen, but there's a star, 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 a star. It's sort of a bent ring with Polaris as the diamond. And
Oh,
so this
that's
is kind
cute.
of a little diamond ring around Polaris, of which that star that I talked about is one of the partners. So as Blake said, you can discover your own little favorite asterism or double multiple star just by scanning around.
That's very cool. There's so many double stars out there. That's amazing. We don't have a ton more questions. The last question that we have is that, actually there's one more that's super minor. How do you turn on the constellations? And it's just a little button down on the bottom left.
Yeah. So the first icon here, and there are keyboard controls for this as well, as Blake knows, but these just toggle. So the first one is the lines. The second one is the labels.
Oh, I wonder if they're asking about like the boundaries of
the boundaries. Yeah, I was getting to that. So the third one is the artwork, and the fourth one is the boundaries.
Oh, I don't know if I've seen the fourth one before. I've never tried it anyway. Very cool. Okay.
And then as Blake showed you before, the fifth and sixth one are the asterisms. So, which in some cases are the same thing. So if I turn off, the Little Dipper is both an asterism and a constellation. So it's shown as an asterism, and it's also shown as a constellation. Oh, no, I definitely recommend folks just sort of play with these buttons. If you get into trouble, just shut the program down and restart it. You haven't changed anything. You haven't locked any changes in, so that's fine.
Perfect. Well, if we don't have any more questions, Chris or Blake, is there anything else that you guys wanted to mention?
I just encourage everybody to get out, enjoy the warmer weather, the clear skies. What do you say, Blake?
Yeah. Yeah, and it's a full moon right now, so you know what to do.
You look at the moon or your doubles.
Make lemon. There's stuff to look at.
Absolutely.
Me. Sure you can.
That's awesome. Yeah, so absolutely get out there, give it a try. Now is the time, as Blake is saying. We have the moon up, so give it a shot. The other thing I wanted to mention is that tomorrow we also have a star party going on in the evening, and we were going to have actual observing, but the folks who are helping us with that out in New Brunswick are getting terrible weather. So we may not have a live view of the sky, unfortunately, but we will have Carissa Campbell, who is doing her PhD on clouds on Mars, and she actually drives the Curiosity rover from time to time. So she's going to join us tomorrow night. I'm really excited to have her. If you'd like to join, I will grab that link and send it out. Thank you to Chris and Blake for all of the interesting content today. I'm so excited to get out and actually try this stuff.
Look for the volcanoes on the moon.
Look for the volcanoes. Look for double stars. And let us know how you did next week. Come back and let us know what you saw.
Thanks, Blake. Thanks, Jenna.
We'll see you guys next time.
Keep looking up.
Keep looking up.